Welcome back, fellow scrubs. Smart D Wiz, preparing for a flood over here. That's why I'm a little late. A little's an understatement. But hey, we're here, right? Whatever. We'll go till the power goes out. Or whatever else happens. Anyway, I'm your host of the Game Dub Scrubs. I'm Mark D Wiz. We're doing Retro Mansion stuff today. It's been a heck of a day for me. So I'm a little discombobulated today. There's a new word. You had never heard that. I don't even know what it means. I mean, I know colloquially it just means that you're all like a mess. But I don't even know if it's a real word. Just people use it. Yeah, it's one of them streams today. Alright, so during the week, we did a lot of stuff. Did a little bit of an improvement to the running animation here. I think it looks not too shabby. He walks back and forth, he runs, and he's going and he's running and he's doing. So there you go, it's run animation. It's not too different from last time. There's several things I'd like to touch up, you know, in addition to that. I don't think that the head is necessarily refined quite to the level that needs to be. I'm okay with the backpack motion, but I think that it could be handled a little better, be shaped a little better. Maybe some tweaks to the shoes and the legs, and, you know, that kind of stuff. But overall, I'm pretty happy with it. At least for now, until I decide that I don't like it, and then just like scrap it and start over again. Hey, speaking of scrapping and starting over again, oh boy, we've got programming updates. Well, not so much that we scrapped it. So Tim and I decided that the version of the platforming engine that we're building, that you've seen previously on the show here, is not that the concept was wrong, but the prototype that we were building has gotten extensively messy, and it would just benefit to write down and understand exactly what the core tenets of the system are, and then go through the process of reprogramming it in a clean manner now that we quote unquote know what we're doing, and to propose, you know, fixing some of the issues that were becoming hard to manage because of the messiness of the code. Now, this is something that's going to be it's not going to be necessarily an easy process, but I believe it's a necessary process to do it. And I've been documenting more stuff than usual, and that's always good. Not so much in this script, but in the surface reference. So instead of, we used to call it line ref, right? It's got to take a minute to load all the references here. We used to call it line ref, and so a line ref was just basically what you see here. When it finds a reference of the line of a surface, so a surface would be like one of the lines that make up this shape here. So this polygon basically acts like a solid object, like a floor or a wall or whatever it is. Now, whether it's a floor or wall depends on, like, you know, where the character's standing and what they consider to be a floor or a wall. And let me get into the specifics here. Oh, hide that one. That one's fine. This is the real meat and potatoes of the whole system. We find out what it is. We get the type of it. This one's a polygon, and then you see that the detection, ray, tentacle, laser beam, whatever you want to call it. It shoots from here and it tries to detect things that are in the way. We technically call it a ray. You can think of it like it's like in a first-person shooter. When you shoot the gun, it has to look forward to see if you hit any targets, right? The hit scan, as they call it. It's basically that. that's how you do that in a first-person shooter. It's called ray casting. You cast a ray from point you want in the direction you want, and you find out what it hits. Now it can hit multiple things, and then you programmatically have to decide what you want to keep and what you don't want to keep. Typically, you use the first thing that you come to, and that's whatever was impacted. And they can be used for a wide variety of things, especially character movement, which we'll get into. So here it found the polygon here, and then here it found the box. It's the second thing. You can see I put a debug marker where it makes contact with this object. And then the orange and the cyan orbs here denote the start and end of the surface that it is connected to. So whatever surface the ray is striking, you get to see what that readout is. And you see that here too. And sometimes you'll see the red line, sometimes you won't. Depends on what debug feature draws first. But you'll see the red here. Should show red, but if the polygon draws after the surface debug, then it kind of hides the red line. But that's alright. That's okay. We can still see the orbs, and that's why I put the little orbs at the end there. And so that's helpful to find out, oh, okay, that's like, what, then you figure out what is it, right? And that's the second step here. It's like, oh, it's a wall, and it's on the right side. And then you get like the steepness value, which is basically just the angle. In fact, I can show that. If I go to the right folder, do I have it? This is one of my favorite Sonic songs, by the way. It just is. Is this it? Oh, hold on, that's the full 360 degree. Maybe we don't have, I think we don't have a example. I don't think there's an example here of the surfaces we have. This one will show you the whole 360 degree, and that correlates to here, this surface world angle. That's what you see. So it's like, it's going between like 45 and 100 because it's rotating here, right? So we get something like this, it's about 90, 91, right? And then we see here that, in our notes, the left wall of an object, its left is 90. So that would be a wall to our right. So that's why we call it a right wall in the perspective. But it is the solid collider's left wall. And then you get the whole 360 degree of movement, because this is flat. If you look at, we're basically judging the surface angle here. If you look at the surface in degrees, 0 is the starting angle, but see how it's flat? And then you go up, and it's 90, and it's up and down, right? Oh, did I okay, hold on. I'm gonna have to put one in a different program that are overriding each other. But see, up and down, 90, flat, 0, slanted, 45. The others, the next available slant, 135, 180, because 180 is the other side of the flat, the axis here. And that's the bottom of an object. And so on and so forth. Until you get all the way to 360, which is just 0 again. Tim's gonna love that I'm working on this. Me and Tim are back going hard on this part of the project right now. We spent a lot of time writing down the concepts and the math that we think is going to be applicable going forward. Hey, can we finally look at this? Okay, cool. It's debug stuff. Let's close that, make it a little easier. So when we get a surface, I have a value to tell if it's valid or not. It's private, but the way that I access it is that I give an implicit operator bool. That's like in Unity when you do exclamation point and then an object name to see if that object is valid before you use it. That's how you do that on your own, by the way. You can make that happen for your own structs and classes. And that's how you do that. So I just have it checked if it is valid. I don't need to do a null check because it's a struct, and I think I can't have a null struct, so I bet it'll complain if I try to do that. So it would be that, yeah, it's like the result of the expression is always false, as a value of type bool is never equal to null. Oh, you know what? No, wait, huh? Wait, value type bool is never equal to null. Why does it say bool? Equal to null of type bool with a question. Okay, well, whatever. The point is, I don't think structs can be null. Whatever that message really meant, structs can't be null, so you don't have to worry about that. But what I do is I set up this is valid value, so that when I initialize it, if everything looks okay, then I say that it's valid. And I just set that to true. And if it's not, it's not. So we have the collider that thing belongs to. This is a surface, remember, surface reference. We're just getting a reference to a surface on a collider. And a collider is just one of these shapes. It can be a box, it can be a polygon, it can be a circle, although we're not going to deal with circles because they're weird. And you can have a line collider too, I think. Let's see. Line collider, line renderer, box collider, 2D, capsule collider. Oh, you can have a capsule collider. Yeah, we're not going to deal with those either. Because they're two circles on a box. Circle collider. Composite? What the hell is a composite collider? Edge collider. I think that's the line collider. Is that what that is? Yeah, I think that's... Hold on. Go back to normal view here. I think that's what the line is, right? Yeah. Yeah, this is the line collider. I don't know if we'll make use of this. It's possible that you could use this maybe for like a thin platform. I don't know about that. I'm not sure how it actually it works here. This is an edge collider. Okay. Well, what happens if we tell this thing to look? Well, it'll find something. Oh, it doesn't like it though. Huh. It can't seem to find points for it. Okay. I probably would need special code for that. I'd probably have to build something to do that. That's funny. That's alright. Oh, I made it only in play mode, so it went away. That's fine. Wait, hold on. Yeah, okay, that's what I wanted to check anyway, if that was that. I wonder what a composite collider is. Alright, we're gonna do some wording. Unity composite collider. A composite collider 2D component is a collider for use with 2D physics. Unlike most colliders, it does not define an inherent shape. Instead, it merges the shapes of any box or polygon that you set it up to use. Oh, that's interesting. The composite collider 2D uses vertices geometry from any of these colliders and merges them together into new geometry, controlled by the composite collider itself. Okay, so this is an efficiency thing. I think what this means is how we've got like 1, 2, 3, 4, 5, 6, 7 boxes here. We could tell it to composite these together into one basic. I think what it does basically turns it into one giant polygon collider, and then it goes from there. So that's pretty cool. I could potentially use that eventually to help get some efficiency. And I'm thinking, because we're doing tile-based graphics, right? Where we have don't break. Had to fix something on the stream computer. So where we have tile-based graphics, right? We'll have, most likely, and I'm just guessing because I haven't gotten this far yet, that our physics are going to be like the physical blocks, the physical objects, in this case the colliders, right? That's what we call them, these things. That they'll basically be represented in that like that grid. So you'll have 16 by 16 pixel, roughly, sized collider boxes, and you'll have a million of them right on screen. So it might be a good idea to have the composite collider take like a whole screen of those and make it just one giant polygon collider, right? Now there are efficiency concerns also with that too. When you have a big shape that has a lot of surfaces, it can be a little harder to iterate through. So let's continue with this and I'll show you what that does. This is a surface reference collider type. I just cache what the collider type is so I can look at it and I know what it is without having to check the type every time. It's fine. Well, and right now we only support box and polygon, so whatever. Over time that may expand, that may not. To be quite honest, box and polygon are probably all that we will really realistically be using, unless one of the other ones proves useful for whatever reason. Either way, segment index start. So when we talk about indexes, I'll start this again. An index is like the, let's see, where are we here? Polygon collider. Let me look at the points, right? So these points here that make up the polygon. This is the index. Index 0, 1, 2, 3, 4. There are 5 points. Oh, I don't want to zoom in on this. I want to zoom in here. And in this particular case, when we get a reference to a surface, we want to know what point that we're doing. And we can see that because I made it write it down. Here. So start and end. So the start and end of the line, I think the start is probably the blue one, and the orange is the end one. It doesn't really matter. Like, it matters, but like not for the display. I don't really care which color is which, but I can look it up if I need to know. And so that's just to get the start and end point in the line. Obviously that's important. You want to know where it starts and ends, right? And then the line between it, it's implicit if you have those points. And then we get to automatically generate the world point of that start and that end here. And so we have all the data that we need. And the surface world angle is, what's the angle of this surface? In this case, it's 92. We already went over the specifics of that. A left wall, a collider's left wall will be 90 degrees, but straight up and down, and this one's slightly bent, so that makes sense. And then negative scale and stuff, that doesn't really matter too much. It's there because if you flip the scale to negative on a collider, it essentially reverses the indexing order, and then it gets a little goofy in the system that we wrote. So we have it that if one or the other happens to be negative, then we reverse our indexes, keep everything flowing smoothly. But that's more of a technical thing there. Then our perspective data, and perspective data is always taken from like the perspective of a character. So in this case, the reason you would have perspective is like, what if Ricky has negative gravity and he flies up to the ceiling? Like in Mega Man 5, in Gravity Man stage, once you get to a certain point, gravity reverses and Mega Man flies up to the top and clings to the ceiling. And then when you jump, you're jumping down the screen and then back up because you're reversed, right? So in order to build that into the system from the ground up, we basically say whatever the character's rotation is just their gravity. It just is what it is. And then you can take that perspective and then you can see, hey, what should be a wall, what should be a floor, and that kind of thing. Because it's very important, obviously, to know what is a floor and what's a wall. You need to know what kind of inclines that you can walk on. Like here, this one's going to be a wall, right? It's straight up and down. Well, sort of. It's slightly bent. But here, this one's obviously a floor. You should be able to walk on that, and sure enough, it thinks it's a floor. And if I rotate this, now the character is sideways. That arrow, that red arrow, represents the right-facing direction. So the character would be sideways, their head would be up here, and their body would be here. Now this should be a wall. Oh, no, I don't want to maximize. I want to go back to debug. Now this should be a wall, and we'll just capture one here. And yeah, sure enough, that's a wall. And it's a right wall, because if our character is standing like this, then to their right, that's a right wall. And so on and so forth. So that's what I've been working to get the basic fundamental perspective data here right. I'll set this back to 0. So right is just right as we see it. Isn't that right? And sure enough, it's a right wall. At 89.96, etc., angle. It is slightly rotated. And then same thing here. So, and then this will be close to 45. Yeah, this is 32 degrees here. And sure, enough of that would be walkable. It says it's a 4. Now we control what is a 4 and what is a ceiling by telling it what angles that the 4 can go up to and what's the minimum angle for a ceiling, right? So a ceiling's going to go up to 180, but the lowest it can go is 124. And then a 4 can start at 0 and it can go all the way up to 56. That gives you a little bit, excuse me, gives you a little bit of wiggle room, you know, when you're considering certain types of surfaces to be potentially walkable. So we would say that 45 is probably realistically about as high, or steep, I guess. That's the word, steepness, right? That's what I've got here written, steepness. That's as steep as the 4 can get before you're probably a wall. So I gave it 56. It's just a test value. Who knows? It might change later. You definitely want your character to be able to walk up a 45-degree angle. I mean, that's pretty standard in the world of video games. And how you want to treat that, you know, maybe you want to drop velocity as you go up and down and all that. That's up to you to decide and how to implement that kind of thing. I would probably just capture this data of steepness and be like, well, anything after 20 degrees of steepness is going to start to show a momentum decline. You know, something like that. I think, and don't quote me exactly, but I think in Mario 3, when you go up a shallow slope, like not a full 45-degree slope, but kind of like the middle there. I don't know, be like 20 degrees, 22 degrees, whatever. I don't think those ones actually slow you down. I think only when you get to the 45-degree angle one that it actually impacts your momentum. That is not the case in Mario World. Mario World, as soon as you hit that small ramp, you start slowing down. And even more to the point, when you're on a 45-degree angle in Mario World, you actually slide down that. You actually get pushed back, which I thought was interesting. It's a bit more of an intense thing than I would have imagined, to be honest. But hey, it is what it is. This sort of gives Mario World a unique feeling, at least, right? So, okay, so what can we do with these rays? We got all this data. What does it matter? What can we do with that? Well, I'll tell you what we could do with that. Get a canvas size bigger than that. That's the first thing. Okay. It's still a little small, right? Okay, this should be alright. Say we got our collider here. That's terrible. We need a different color in the background. Hey, it's Sonic Boom! Damn, I love that song. Crank that shit. Crank it on mine, it's not here. Unless you want me to. Okay, we've got our... Damn it. We've got our collider here, right? You know, hold on. Let me make them boxes. Might be a little easier to understand here. Okay. This is our floor, right? And we can even make it shaped like this. And I'm gonna say that this... that's a dark color. This orange box, this is us. This is Ricky, right? Sonic Boom, Sonic Boom. You're not here to hear me horribly, horribly sing. We'll move him a little over here. So when we move, we can use these rays, right? We can use these rays, you can see, to detect what's in front of us. So if we shoot a ray from the corners here, then we can tell where this impact is, right? We can tell what's going on here. And we know that they hit on these parts of the wall. And one thing that I think is not here... Oh, you know what? It's because I hit it. So when you get... This is the actual raycast data that you receive back once you shoot one of these, right? And it can say distance. Now that's important. How far away are we from it? Well, we're 1.45 units away from it, which makes sense. Here's a whole unit here, and then there's about a quarter here and a quarter here. Well, it's almost 1.5, and that's what we see. And as we get closer to it, we can see the distance decreasing, obviously. So as we're moving, if we say, oh, not here, if we say we're going to move this full length here, this full distance, when we press right on the D-pad, then now we can say, hey, actually, let me make it a little more obvious. Say we move this far. We're going to move this far. Now, obviously, before the end of this arrow. Cool to see your other projects. Great to learn from. Well, thank you. If we move, we want to move farther than this wall will let us. We shoot the ray out, like we have here. Oh, look at that. You get the distance. And now what you can say is, well, I was going to move these 20 pixels or whatever, but instead of moving all the way, why don't we just find a distance between the wall and us? And then we just move up to the wall. And that's it. And then we stop moving at that point. That's the basic idea of what's going on. And we should be able to do that. So why don't we? Let's take this. And I'm going to make a new script here. It's gonna be move ray test, right? Yeah, that don't matter. It's only a test. Okay. We're gonna need... actually, we're gonna need collections generic, because we're gonna need a list here. Private list vector 2. And we're gonna call it world points equals new list. This is just gonna be a garbage collection friendly way to collect these points. So we're gonna have a public collider 2D. Actually, we're gonna specify it's a box collider because this is going to work best with boxes when you do character movement like this. This is the Nintendo way to do it, or at least as far as I can, as far as I've studied, this is the Nintendo way to move things. And they're like the way that they cast their rays and stuff may be different, but just based on observation, this is what we reverse engineered. But the important thing is that when a character... Now, we won't be able to do this in the test, because it's going to take a while to develop this, but if you have... if you've got... Not what I want. You've got a triangle, a nice straight triangle here. How about that? And we want the character... Oh, stop it! We want the character to sit on that, but really what we want... We don't want them to sit on the edge. That would look stupid. Like, if it was Mario, Mario's 1 foot would be over here, and 1 foot would just the tippy toe is touching the ground. That would look stupid. So we need to go. We want to put them flat, like in the center on the surface that we're using here, right? That makes sense. That's the Nintendo way to do it. A lot of people don't seem to understand that. So then you get weird looking platforming engines that have like the corners of the boxes or what's walking up and down the ramp, and it's just not... It's not how we used to do it back in the day. And of course the techniques have changed because we're using rays now, and we don't have strict pixel tiles and things like that anymore. You have to compensate for almost anything in sort of an infinite precision space. And that's the real complication of this whole system. In order to get this to work, not quite that easy. That's why we're still developing it for so long. Let's see, chat says you can change the templates for scripts. Please change the main template to automatically start fresh with no start and update. It's alright. I don't mind the fact that it... Yeah, I know you can... What he's saying is that when we started here... Just trying to back this up. When we started here, it gave me the class and it gave me the mono behavior and all that stuff. Yeah, you can definitely change all that. I don't mind it being there. It's not too big of an issue. At least it puts the class with the name there. If I don't want it to be a mono behavior, then I'll just do this and call it a day. But yeah, you can definitely do that. So we want a box collider because that's what we're dealing with here, right? We got a box. And that's easy. You can get a center point on the bottom, and that's where you do that. Now that's a few steps ahead, so we're not really going to be doing that yet. But that's just to explain why we have the box. So, box collider 2D. And now, lowercase d. Then when we do awake, we want to first check if that box collider is good or bad. If it's not, box collider was invalid, then we don't want to do anything else. And in fact, we're going to disable the object And we'll throw an error. So this, then that's just going to copy the name of the object that we're in. Luke Morris says hi. Hello. How's it going? We're just going to say the same thing. Box Collider 2D was invalid. Disabling script. And then comma this. I think that just gives Unity more information if it's a Unity object. What's up? We're talking about platforming and raycasting. All the stuff that Tim keeps bugging me to continue working on. It's just kind of a grab bag day tonight. Yeah, wait for the floodwaters to kick up and the electricity to go out. So we'll see how it goes. We're up in the mountains. We got it's kind of a rural thing. Hey, of course, thank you for that follow. Your screen recording is so good. Well, thank you. I know we only stream at 720, but it's more of a bandwidth concern. I don't know, I got better upload now. Maybe I could push it to 1080. I don't know if the computer could process it that quick. At least at 60 frames per second. I'd have to do a test on that. But I try to make it as clear as possible. But yeah, I guess the other thing too is that, like, you know, once you push the quality of the stream so high, some people can't even watch it. It doesn't come through on limited connections. There's a lot to consider. I'm glad that it's good already. So, let's see. Okay, we gotta check to see if that thing's good, and if that thing's good, then the next thing to do is to box collider 2d.get world points. Now this is something that I've created. And we feed it a list, and it's going to fill this list with the points, right? Now this is an extension method. I learned about this fairly recently, within the last year. So in C#, what you can do, because box colliders don't normally have this method, you have to, you know, do whatever you need to do to calculate the points, which I go through here. And, you know, it generates the points, transforms them to world space, and then it spits them back. So what you do here, in order to add it to Box Collider 2D, you have to make it a static method. And then you know, obviously give it the name, but then you do this, Box Collider 2D, Box Collider 2D, and then it just makes it. Like, I can do one here, public static int get the number 2, and then just return 2. But what I do, we'll just copy it from here. This Box Collider 2D. Watch, I saved this. Watch what happens. Where were we here? Move this. Watch this. Box Collider 2D that get the number 2. It literally adds it to the list. Isn't that great? So that makes it really convenient, because otherwise you might have to make a static class and then make one that you have to pass it in, and so on and so forth. And that's a pain. You don't want to always do that, so I will get rid of that. But then you could just add it here. And since it concerns the Box Collider 2D, it makes sense. It goes through, it gets the extents and the offset and all that stuff. Hey, wait, am I actually using the offset? Yeah, I am. I was gonna say, wait a minute, I didn't see it. But no, the offset's working. Okay. Yeah, it's really cool, right? And I'd never known about it until this past year. It's really, really useful. I don't know. I'm assuming that it works in .NET 2. But I usually set my projects at .NET 4.5 or whatever the most Unity allows, by default at least. I mean, I think you can force it to go higher, but it gets strange results sometimes, so I don't bother with it. I just use whatever the not necessarily recommended, but whatever Unity allows without monkeying on it. Chat says, I tried making my own game, but I can't wrap my head around the coding. I gotta get a character controller, but that's it. Coding's tough, but we do have... I really should keep, like, a thing for this. Hold on, let me get you a coding tutorial that might help you. If you're using Unity, at least. Here we go. Good old Bob. Where's my chat? Here's my chat. Yeah, you use Unity? Yeah, there you go. Good old Bob. He's gonna teach you the C# fundamentals. If you take that course, you'll know what to do. Just get through that whole thing. If you can get through that whole thing, then you'll be off to a great start. I would say do that before you even bother trying to mess around in Unity. Good old Bob will teach you. He did Microsoft paid him to do that course, I think. Because Microsoft actually develops C#. It's their little baby, and it's pretty good for stuff. It's not as advanced as... Okay, advanced is the wrong word. It's not technically as powerful as C++ in terms of like efficiency and memory control and stuff. But it's beginner friendly enough that you could just kind of get in there and start doing stuff without having to worry about creating memory leaks and all that kind of stuff. So I understand why Unity went for it. Anyway, so we get our world points here, and what we want is we want the corners, right? Where these rays are going to be firing from. And that's exactly what we've got now. So let's see. We want to look... We're going to copy this into the other file. Those notes there. Because I think they're going to be very helpful. Let's see. This is 2. This one's 3. This one's 2. We need to know what indexes these are. This is 1. Thank you for it. We'll find out real soon. And this one is by process of elimination of 0, right? Yeah, so there's our points. And we're gonna use these to fire off in different directions here. To make life easier, I'm just gonna do top left. Let's just do this. Top left, top right. 2. Bottom right. And bottom left. So let's do that. So top left is going to equal world points 3. And just copy that. I'll just go 2, 1, 0. Top right. Bottom right. Bottom left. And we'll actually test these one at a time to make sure these are actually going in those directions. And then, yeah, that'll be fine. So let's do a test first, right? So I'm going to shoot, let's see, gizmos.color orange? No, cyan. Do something. No, you won't be able to see it, right? What's the color in the background here? Oh, you'll be able to see it on here at least. Let's change that background color. Let's make them less saturated. How about that? That's alright. And we can actually see. Oh, that's a little bright. So let's turn the value down. That's much better. Oh. If you want to ever test one of your games, or want me to test one of your games, I have a Fiverr gig. I've got enough testers already. I appreciate the offer though. Let's see. Yeah, so cyan. And then gizmos dot draw line. Oh, we need some properties here. How about a public move speed? And we're gonna say that's 1F for now. Oh, I'm sorry, it needs to be a float, right? Give me a decimal. So if we say, what's the first parameter? The from. So let's try from top right. From top right to, oh, I see what it wants. Top right plus, and it's going to be the destination of the line. Now the rays don't really work like this, so you've got to do a little bit of math to get the debug line to show up here. So they want a start and ending point, right? So we say we want the starting point, and then the starting point plus transform dot right, which is the right facing direction, times the movement speed times that delta time. Remember, everything is a time enabled action here. So let's see, it's going to have a problem in that transform.right is a vector 3, I think, so we need to say that that is a vector 2. Yes, and now it stopped its belly aching. Okay, and then we'll see if this is actually coming from the top right. How about that? Where did we put that? Nope, that is absolutely not what's going on. Oh, you know why? It's because we didn't feed it the proper thing. See how we didn't give it the box? You've got to give it the box. How about that? Okay, so can we see... this is a bad color for the character. We're going to change that. Hold on. Uh-oh, what I hit edit. What's it going to do? Oh, it's going to send me here. Let's go back. Can I? Oh yeah, here we are. Let's make this like orangey yellow. Oh, no, you see here? Okay, our points are wrong then. That is not correct. What is going on? Divided the shape. What if, wait, hold on, maybe we gotta play first. Oh, maybe. Alright, now what? Oh yeah, here we are, top right. And there's our little line. How about that? Kinda hard to see if it's going across here erroneously. Let me make that, oh, wrong one. Let me make that green. Might be a little easier to see. And just to make it even easier to see, let's make that dark. Yeah, okay. See, it's coming from the top right. No, it's not a big line, man. Like, you can barely see it when you're zoomed out. Oh, we can make that better. So if we make it move speed like 17, then you see here, it becomes bigger. Might have jumped the gun there. Sorry if it was genuine. I'll let Mark decide that. What did I do? Tim, what? What's wrong? What'd I do? What did you do? Oh, the advertising? Oh, I don't know. It still shows on my end. It's fine. I'll let it go. That's fine. He's an actual viewer. He can live. I don't know. Did you ban him? Please don't. Can you unban him? What happened? Don't ban him. I can understand if you just walked in though and saw it and like, okay. No, it's fine. Don't kick him out. Oh, you just deleted the message? Okay, that's pretty harmless. That's fine. I still see it on my end, but mine probably doesn't refresh. That's okay. As long as you didn't kick him. Anyway, so this green line is supposed to represent essentially how far we intend to move going to the right. And so we're going to shoot out these from all four corners of our collider. Yeah, that's alright. I get you. I understand where the confusion came from. I can't blame you on that. Okay, so then, top left. Bottom left. Now again, this is just a quick test. Oh yeah, we should make sure individually that all these are actually accurate to what their labels are. So this one's top left right now. Well, it's... This is going to be hard to see, isn't it? Because it's... Oh no, or is it gone? I should still be able to see it, right? If I close that, and that. Oh, I had the frame advance. Yeah, there it is. That is top left. Okay. That was top left. This one should be bottom left. And, yep, lo and behold, that's bottom left. Now look, there's only one by process of elimination, but just to be thorough, right? Let's do bottom right. Hey, look at that. Okay. Alright, we're good there. So every single one of these is in the right spot. They're with the right label. So here's what we're gonna do. On update. You know what? I'm gonna turn this to on enable. Oh. I think that'll be better. That way, if we have to correct something, then we can just turn it back on, and it will attempt to redo these points again. Hey. It's that Sonic CD, man. That soundtrack is crazy. Love that thing. Okay, so what we're gonna want to do, we'll start with casting one ray, okay? Just to get the concept. We're gonna do the top right. So I'll disable all the other ones from showing up. And we'll do that top right. And what we'll say, well, we'll have, private static list, raycast hit 2D. Raycast results, I'm not gonna say hits, raycast hits. Now we make this static list here so that we don't have to keep creating and destroying it, and that creates garbage collection, which slows your game down. I've been learning that the hard way. Cleaned up enough of these cases to start to know better, right? So first things first, physics 2D. If I spell it right, I guess it would work. Raycast all. Now the difference between raycast and raycast all is raycast will stop at the first thing that it comes up against, and then that's it. And raycast all will get you a list of all the stuff here. At least I think it can give you a list. Don't tell me it can't get you a list. Well, we need to fill in the information at least. So top right is our origin. It's where we're going to be firing from. Our direction is transform that right. That's the it's the direction we're moving in, right? At least for now. And you know what? Let's do this. Vector 2. Put ray direction. We'll do it up here. So we only have to change it once. If we want to. And distance is going to be our move speed. Actually, let's do this again, just like we did before. Float ray distance equals move speed times time dot delta time, and that keeps the movements consistent the way that Unity works. Now, if you're using fixed updates, you want to use fixed time and so on and so forth, but if you're using Unity, I expect you know what those things are, so all depends on the kind of game you're making. So ray distance, or no, yeah, distance, there. That's all that's technically required. Now, there's a layer mask, minimum depth, maximum. I don't know what depth means. We could look it up. Wait, so they don't, hold on. They don't have a way to get them as a list? What did I do in the other test? Oh, I just got it as an array, apparently. Well, that's not good. That's a garbage collection nightmare. Okay, there's gotta be a way to do this. What else? Raycast non-alloc. Oh, that might be. Yeah. No? Wait, okay, we're gonna have to look this up. I don't want to fall into a garbage collection trap, so... Raycast non-alloc. What does that do? There is no raycast. Did I spell that right? Raycast non-alloc. ALLC. Put the parentheses on? Oh my god. Okay. Raycast, raycasters. Physics 2D raycast. Raycaster. Raycaster. No, that's not what I want. Okay, how about raycast all? General optimization. What is going on? Okay, we'll go to physics 2D. This really shouldn't be this hard to find. Physics 2D. Okay, maybe we're getting somewhere here. Physics 2D. It doesn't. Wait, what? Where's the mod? Where's the methods? What's this? Oh, here we go. Oh, sure. Alright, whatever. Structs. Wait, where's Redcat? Class. Structs. Wait, that's module. raycast hit duty. Okay, maybe it'll tell us from here. There we go. That raycast. So if we go back to physics 2D, can we see it here? Okay, this looks different. Okay, I think we're in the right spot now. Raycast, all raycasts. Oh no. Okay, take a look at them. Yeah, well, so what does this mean in depth? Only include objects of a z-coordinate depth. Well, that's handy. Even though it's 2D. That's handy. Okay, so non-alloc returns the number of results placed in the results array. Cast array into the scene. Note this method be depreciated in future builds. It's recommended to use raycast instead. Okay. Function is similar to raycast all function, except the results is returned in the supplied array. Integer return value, number of objects, blah, 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 possibly 0. The results array is not resized if it doesn't contain enough elements. This is what I want. Why is this being depreciated? This is what I want. I don't want to create a new array every time. That generates garbage, right? It's killing me. Line cast. Wait, what's a line cast? Oh my god, I'm learning everything today. Cast a line segment against colliders in the scene. Isn't that what array is? It has a length, so it's a line segment? Okay. Line cast is an imaginary line between 2 points of world space. Any object making contact with this line can be detected and reported. This differs from the similar raycast in that the raycasting specifies the line using an origin and direction. Okay. Wait. But that's the same thing. This differs from similar raycasting. Raycasting specifies the line using the origin and direction. So this is the same thing, it's just you provided an endpoint instead of an origin and direction? Okay. Okay, sure. I guess. I think this is the same thing as raycast. It's just you give different parameters. This function will allocate memory from for the returned objects. You can use non-alloc to avoid this overhead if you make line cast frequently. Yeah, except you're telling me that it's going to go away. Why would it go away? Why can't you give you a list? Alright, I'm getting mad now. It's literally telling you it's getting depreciated, and it's recommended that you use raycast instead. I'm getting mad now. Start to piss me off. Raycast off. Like, this is the one I want, but it's gonna create an array every time, and that returns garbage. Okay. Function similar to raycast instead of detecting just the first collider it hits. An array of all colliders along is returned. Colliders in the array are sorted in order of distance. Yes, the layer maps can be used to detect objects selectively. Right, okay. This is wonderful. But you're not going to let me use the non-alloc version in the future. Alright, I guess we're just going to accumulate 10 tons of garbage for now. Thanks, Unity. Alright, var results. Alright, and don't worry about this list. I thought you could send it a list, but apparently it doesn't want that. Oh, you can add the results here. Wait, oh no, because I'm using non-alloc. apparently doesn't want me to use. Float distance, wear mask. Yep. Okay. So what we'll do here is for the results, like a for loop, standard procedure. We'll loop through the results, right? Alright, we'll extract the result. And let's see. I can't believe they're getting rid of raycast non-alloy. There's got to be another method to do it without it if they're getting rid of it, right? Why would they force you to create an array every time? That doesn't make any sense. Knowing that C# is vulnerable to garbage collection. Wait, or does it only work on classes? Does garbage collection only work out if you have... Alright, hold on, we're gonna look this up. Maybe it only occurs... Let's see, C# struct array garbage collection. Maybe it only happens when you do classes. Oh. Go to Stack Overflow, everybody's favorite copy-paste arena. Okay. What's going to be the difference in heap and total memory if I have an array of ints compared to an array of classes when these variables go out of scope for garbage collection? No, it's not a silly question because I'm here too, buddy. Nobody answered it? Wait. Wait, what? Nobody actually specified an answer? Let's see. The difference in behavior between an array of structs and an array of classes is that the array of structs is one large memory allocation. Okay. An array of classes, yeah, okay, I know that. But I want to know about... He's asking about garbage collection. Nobody's talking about garbage collection? Alright, hold on. Back to Google. What's going on here? Saving memory with structs. C# or C++ is low difference. Yeah, blah blah blah. Okay. Is this is like a fucking book. I'm gonna be looking for this answer all night, aren't I? Power structs. I wanted about struct arrays. I didn't see anything about struct arrays. I think that's just normal struct versus whatever. You know what? Screw it! I don't care. I'll look it up later. I don't care anymore. It's killing me. Okay, so here's the thing. The hit has a distance, like we said. So you can say, okay, we can use that distance to shorten our trip, right? If we bump into a wall, we don't want to go through the wall, we just want to go up to the wall. So we would say that the first thing that we hit here. Let's do this. Float tended movement distance equals ray distance. And if the hit dot distance shorter tended move distance equals the hit dot distance. Makes sense. Seems a little redundant, but it's not. Trust me, we'll get there in a minute. There's a reason I set it up this way, but we'll get there. That's when we have multiple arrays going off, and you want to collect the closest one. Now we do run into a problem, and you'll see here. I'm pretty sure it will be a problem. He's not gonna move. See, I'm updating it. I let it go. He's not moving. Wait, what's going on? Oh wait, hold on. You know, actually that's also because I'm dumb. What I need to do also is to actually apply the movement, right? There. Okay. So that's transform. Position. I will say local position. Can we just do a plus equals now? I feel like sometimes you can. Ray direction times intended new distance. Oh. Not only did I not get the 3, yeah, you can just plus equals. Okay, this still is probably not going to work though. I'm expecting it not to work. Yeah. He's not moving. How come he's not moving? Right? Got the thing here. We checked for the distance. There should be nothing in our way. We applied the thing here. What's going on? That is a simple answer. You're a collider yourself, so when you shoot a ray, you're gonna find yourself. And I can prove it here too. Oh, I need to add using the Sky Platforming engine. Serializable. We're gonna save these. Breakcast hits the add range. This is just so we can see them in the editor. Oh, I didn't like it. What didn't it like? Oh? Oh, you know why? Okay, no, that's fine. That's fine, that's fine, that's fine. I have to transform them into the serialized version. In fact, let's go here. Save into the debug readout. New. Raycast, serializable, and we feed it. And that should work, right? Oh, I'm sorry. Results are. Alright. Or, well, since we've already extracted it, just use hit. We'll do that. That's efficient. Okay. So we're gonna see. Nothing. It's because it's private. Right? Yeah. Oh, and it's static too. Jeez. This will not be public. Public! Excuse me, there we are. Now it's here. Uh-oh. Oh, hold on. I gotta clear it out every time. That was my fault. But you did see it fill up with stuff, right? And what it's gonna fill up is it's gonna fill up with itself. Collider box, Collider 2D from player. There it is. He's trying. See the little dot? He's trying to move. But he's hitting the player, and look at that. Distance 0. Okay, so what does that mean? It means we hit ourself. We are also a collider. And we will hit ourself when we shoot a ray from our top right corner. So how do we fix this? It's actually quite simple. If... You know what? I'm going to move this down here so that we'll always see it in the stack. If hit.collider equals box collider 2D. That thing we checked up here, we store that. If that's the case, then continue on with the for loop. We hit ourselves. Don't count that. And look at that, he's moving! And he went through the wall! Why did he go through the wall? Alright, we'll figure it out. Why did he go through the wall? What happened? Did you not see it? Alright, hold on, back up. That's funny. Anyways, he's moving now, right? He didn't see him! You didn't see anybody? How come he didn't see anybody? What's going on? He didn't even see it himself. Hold on, something not right here. What did I screw up now? Uh-oh! That's what it is. Arrays stand in place. That's what it is. We generated our world points in one spot and we're not updating them. So what that means is we have to continue to generate our world points over and over again. That's alright. So we just moved that down to update. As long as we have the collider, it will work. Welcome to programming. He's gonna stop? Yeah, he's gonna stop. There we go! Look at that. We found ourselves, and then we found Solid 3. Guess who that is? Who's this guy? Bonk. There he goes. So that's the whole deal. Once you get to the point where you're moving zero distance, you've stopped, essentially. You continue to try to move right. So if I get rid of this guy, he'll keep going. Now he's not checking his bottom corner, just his top, just FYI. So he's gonna go right through there. But I put this guy in his way, boom. If we put it right here, boom. Okay. But if we put it down here, of course, he doesn't have a bottom right array. Or ray. Not an array. A ray. Okay, so you're like, okay, fine, whatever, that's cool, right? Alright, what we need to do is we need to do the rest of them. We need rays on all four corners. Now, there's the intelligent and the not intelligent way to do this. The not intelligent way to do this would be to do it on the top left, do the loop again, copy it again, bottom left, etc, etc. Now this will work, but it's pretty ugly, right? So I hope it'll work. Let's find out. I think this looks right. Yeah. So this should catch on all four corners. If something is impacting it on all four corners, it should pick that up. Let's make sure that's actually the case. Okay, and then we're gonna get rid of him, and he should stop on the bottom right. There you go, boink! And he hit his bottom right corner. How about that? And the other corners are firing too. They don't technically have to, but they will. It's important that the other corners fire when you're going in different directions, so you'll see that. You can optimize it a little bit here and there. That's the basic. Okay, so how do we pretty this up? This looks terrible. We do something called refactoring. Refactoring is a fancy word for saying, I'm going to take this code and I'm going to put it in a different method so we can reuse it. Private. You know what? I'm going to return the remaining movement distance. You'll see what that's for. Yeah, I think that's what I'm gonna do. I'll return the remaining distance, and so process corner ray, and we're going to need vector to corner origin. Oh, let's capitalize that properly. Nice. Float, move distance. Is that all we need? We got the direction. Oh yeah, we need the direction, right? Vector to ray direction. Oh! Oh! I pressed a control and R, I think. Ray direction. I would just call this ray origin instead of corner. Right? Nah, corner origin. I don't know, it doesn't matter. As long as you know what the hell it is. Okay. And then we'll cut this. Paste it here. And now ray distance can be move distance. And we'll put move distance here. And we return move distance. So move distance will get manipulated. We fired a ray with the intended distance. And then if the distance is less than the move distance, well now that's the new move distance. Update the move distance to the minimum. How about that? Yeah. Yeah, that's good. And then we'll return move distance. So then we're just gonna play pass the ball from one thing to another. Going to race. No, that's fine. We'll do this. We'll do this. I'm just gonna call this move distance as well. And so what we're gonna do here is move distance. We're getting the new move distance equals top right. Right direction. And move distance. And we do that 4 times. Top left. Bottom right. Bottom left. You know, each time, move distance potentially gets shorter and shorter and shorter until you get the final move distance. And then you use that to move. So move distance starts, well, say that starts at 0. Oh wait, no, right, okay, hold on. You know what? Here, move distance. There we go. Move distance starts with our move speed times delta time, right? Then it gets sent to the corner ray to fire, and if it impacts anything, it will shorten that distance and pass it back here, which gets sent to the top left. Now the top left doesn't have to search as far. We already know that we've bumped into one thing. We're only concerned at this point with further shortening our movement. So it sends it to the top left. Say it found nothing. So we started, say, with a movement of 1. We got a movement of 0.5 because we hit something up there. Now the bottom right ray, maybe it hits something at 0.25 distance. That's even shorter than 0.5. And then it'll go through. It only has to search 0.5. It doesn't have to search the whole 1. We already know that we bumped into something at 0.5. So we keep reusing and minimizing the distance as we go along. Hey Red Pug, what's up? All the way until the end. And then whatever we end up with, that's our final move distance. It's going to be the shortest distance. So it'll be the distance to the object that is closest to us. We whittle it down by process of elimination. Yeah, I like Sonic music too. Hey, Sonic's cool, man. So this should work. We should be able to bump into any of the corners. Oh, and show all the rays now since they're all firing. Oh, yeah, they won't actually be showing their full move speed here because we're truncating it each time. We could record all 4 of these move speeds and accurately do it. Just know that this is the maximum possible move speed. It's not an accurate reflection of that truncating value. Okay. And here we see it moving on all 4 corners. And there you go. Boom. Bonk. Uh-oh! We got a problem. What happened? Did not find anything? Wait. What happened? How come you didn't stop? Oh, that's cool. Chat said that even though they watched the Pocket Fighter streams more, they were introduced to the channel through the Retro Mansion game. That makes me happy. Makes it feel discoverable. Alright, let's figure out what the heck's going on here. Okay, this should be seeing something, but apparently it might not. Oh, it is! Wait, so what's wrong? Oh, that's just us. It's only seeing us, huh? Did I not replace these correctly? Bottom right, top left. Or top right, top left, bottom right, bottom left. Okay. Well, now what's going on here? We're gonna have to put a breakpoint, I think. Wait, no, it's only. Hold on, it's only bumping into itself, though. These are all the players. And those would be from the 4 corners, so shooting 4 rays, right? Why is it not detecting this? Why is it not detecting that? Alright, hold on. Alright, you're getting turned off for a minute. Let's grab our raycast tester. Okay, it can see the surface. Obviously. Solid 1. Yeah, we see it. Yeah, solid and solid 1. It's there. So how come our raycast didn't see it? Okay, let's look. We are doing the points. Have something with move distance, perhaps? Something to do with that? Oh, this is why. Oh, okay. You gotta be careful when you refactor stuff. This was hard-coded to top right. But this needs to be corner origin. It actually wasn't firing the rays. What you got down here, I was saying that these are just mock representations of what we were doing. That's why it looked right, but it wasn't working. Yeah, so corner origin has to be here. That was my mistake. Okay. Now we should be. I say that a lot. And bonk. Yeah, there we go. Okay. We're all set then. Bonk. 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 There we go. Now, if we do a negative move speed, I'll start to move left. And then we can test. Uh-oh. Oh no! He's not going. Okay, I think I know why though. Because the ray is still casting The move direction is negative when we do that, I think is the problem there. We end up moving left, but because our move direction is negative, it's not going to get checked here as being any different. That's okay. Our move speed should always be positive to help alleviate that issue. And if we need to turn around, then the ray direction needs to turn around, right? Because we're going to be moving in that direction anyway. So we can do a negative ray. And then I'm going to also do... Alright, chat says, do you think you can make a fighting game in Scratch? What is in Scratch? What is Scratch? Or do you mean from scratch? I mean, I've already done that. But Pocket Fighter EX. Or Scratch a program or a platform? I don't understand. Can you elaborate? Sure. What was I gonna do? Oh yeah, I'm gonna do an on validate. So that whatever is typed into move speed, math F abs for absolute value. Scratch is a drag and drop coding website for kids. I can't answer that. I don't know, and I really don't have any interest in Scratch, so I couldn't tell you. I don't know if it has all the features that would be required. Unfortunately, I don't have the time to figure that out. Okay, this will help. Alright, so if we do a -1, it's just gonna make it 1 again. That way we can never go backwards that way. So here's the deal then. What we're gonna do is we're gonna do negative transform.right, and what that will do is it's just gonna have us go backwards. And this one, it should actually work. Yeah, well, that one works because we've changed the actual direction that's being processed here. So, see, donk, donk, donk. That's all right. Do I like anime? Hell yeah, I like anime. I like Street Fighter, right? How would I not like anime, right? Street Fighter's basically anime. It's very anime. Yeah, I like it. Of course. Right now, let's see. What am I watching? Shows are ending because it's the end of the season. And I'm still watching Attack on Titan. Dragon Quest Dai is alright. I watched that. I'm not like super enthused about it, but it's alright. I watched that one. I'm watching Jujutsu Kaisen. That one's alright too. That one's starting to get a little annoying to me. Oh, yeah, I'm up to date on Demon Slayer, except the movie. I guess the movie hasn't been translated in English yet. I don't know when. Honestly, I haven't been paying attention, so maybe it's out and I just don't know. Because it was actually like in theaters, right, in Japan? So then you gotta wait for it to come to home release, and then hopefully they'll translate it. I'm pretty sure they will, because it's pretty popular. It's alright. I thought the Blu-ray ain't out yet. Okay. Yeah, okay, then yeah, there's no chance that it's up. I'll be honest, I liked Demon Slayer's like first 4 or 5 episodes. I thought it was really, really good. But once I started including the side characters, I think it actually diminished. I didn't think that they needed to add the side characters. I thought that the main character and the sister were good. Like a good combo. And then now it's, I don't know. It felt, maybe this might be how the anime was portraying it. But it felt more grounded and serious when it was just the main character and the sister. And then when the side characters showed up, like it got kind of goofy, it felt like. Because they were kind of goofy. And then the actual like Slayer Corp captains, whatever they are, they're just like walking stereotypes, and I hate that. Like, they're really annoying. They're just walking tropes. They're like not even characters, they're just walking anime tropes. And at that point, I kind of like sort of fell off the boat. Like, I watched it, but I just didn't. It didn't jive with me in that way. I thought it had an extremely strong start, and to me, it kind of just fell apart from there. Like that first part with the training and the boulder and stuff, all that was perfect. That was exceptional stuff. And then the other stuff hit, and I lost interest. It is what it is. I know it's popular. I know people love it, but I don't know. I can't stand like tropey characters that are just the character is defined by one personality trait. Like, they're not like a real person. They're just that's the character that's mad about stuff. Oh, okay. That's great. But that's not an interesting person that like I want to know about. Next season is loaded. Yeah, see, I haven't seen the movie. I don't know what that's like. So I don't know if it gets better or not. Hey, 664. Yeah, I don't know. I don't know if it gets better or not. Oh, you mean the spring season just in general? Okay. I mean, I'm assuming that Demon Slayer is going to keep going. It had a giant run. Like, the manga sold gangbusters. I don't expect that to, like, not continue. But I don't know if they've announced a new season yet, since the movie ended. Yeah, what is in this next season of anime? I think My Hero Academia is coming back. I want to watch that. Now, I'm assuming Titan might take a season break? Like a split season thing like they did last time? Oh yeah, that's right, Megalobox is coming back! What do they call it now? They call it something else, but yeah, it's Megalobox Season 2. I forgot that that's coming this season. Oh, I don't know what 2 Year Eternity is. Megalobox Season 2 though, that's gonna be my show of the season, I can guarantee it. That was such a good show too. It hit like everything. That's a show like, I'm talking about characters, like interesting people as characters. That's a show that excels in that kind of thing. They have characters they're not just one-dimensional, throwaway personalities. They're actually doing stuff. I like how I can just kind of analyze anything with this. It actually makes it really helpful. I can just check the readout and see what anything is. Okay, so here's the thing. We can do... because we're using transform.write, correct? So we can actually... oh, that's not controller. We can start turning this. And he can start moving in different ways. See? How about that? Just by rotating. Now we don't have to make it do it this way, perhaps, or necessarily. But that's because we built that direction into him, that he can go anywhere and detect stuff on those four corners. Now there's a problem. And you want to know what that problem is? We're only detecting the four corners, so what happens if we hit the corner of something else? Oh, he's seeing... I can't do that there because he's seeing the polygon. I'm going to turn the polygon on so he can get past it. Uh-oh, what's going to happen when he hits... What's going to happen when he hits that corner? Any guesses? He's going to go into it. Uh-oh, SpaghettiOs. Yeah, we don't want that. Your To Your Eternity is the second manga by the silent voice author. Okay. Yeah, I saw the Astro trailer yesterday. It's alright. I think they should do a little more because he doesn't use like any energy things, you know what I mean? I think that they should do more to like sell the power of his hits. You know, kind of like Vanessa has like little wind effects and like just like generic power effects to her moves. They kind of sell the fact that it's just physical blows. I think they should do something like that. Or give more violent screen shake or something to like his big moves. They just look a little underwhelming compared to the rest of the cast that's throwing out fire and ki blasts left and right. I feel like they could do something to bump that up. To Your Eternity is a fantasy story about an immortal being meeting humans across the ages. Okay, on paper I could probably dig that. Kind of have to come down to how it's written. I think the author definitely has the potential to write something good there. But yeah, okay. So what's the problem here with this guy? Why is he going into the corners here? Well, it's because when he's detecting, he's shooting out these rays. Oh, I don't know. When he's shooting out these rays, they're only going to shoot and detect what's in front of them. Well, it's not going to see that spike. And it's like, ah, crap. Alright, so how do we fix that? Well, I got an answer to that. It's called a reverse ray, or I call it a reverse ray. We can use the same functionality that we just used to detect that. Detect all sorts of things. So let's grab this color. So, say we have this collider here. And we have our box. And we're going this way. Well, if we move... Let me get it. If we move this far, right? We can move this far. We didn't hit anything. These rays didn't hit anything. You see the blue doesn't touch the green. And so right now we're saying, okay, we're going to move over here then. But, uh-oh. We got punctured here. We went inside this collider. What happened? That's because our rays aren't going to see this here. So what can we do? Well, why don't we shoot a ray back? Right? Let's see, this is how long? Well, tell me how long that is. 8 pixels? So if we shoot in ray 8 pixels, well, by golly, look at that. We actually made contact with our side here. What do you mean test with bigger colliders? Why do I have to test on bigger colliders? Nothing wrong with this setup. I still have points. Listen, just let me be Tim. I'm teaching him how to do the thing. Don't need bigger colliders. Okay. So it hits him, so what can we do? We can say, okay, well this is 8 here. I don't understand what you mean. I'm just gonna do this. Okay, we got 8 here. And we've got 8 here. But here, we hit early, so we got 7, right? We got 7. And what we're going to take is we're going to take 7 as our minimum. Obviously, it's less than the 2 8s. Alright, let me think. How do I want to do this? Well, we have to detect this thing somehow, right? No, reverse raise should come first before we do the line walking. Oh! I think that's my, I think that's, yeah, that was my track name notifier here. So like where it shows the track name on the bottom of the screen. That's what that was. It crashed. Alright, where is it? Where are you? There. Snip. Called Snip, if you want to know. Now, I think the reverse race should come first. Line walking, that has to deal with the center points and all that. That's too much to set up right now. So we want to do the reverse race. Alright. How do I want to do this is the question. I'm probably gonna have to do a quick and dirty one. So we need to know what we could potentially be bumping into so that we can shoot the reverse raise back. Because we don't know where any of these points are. Whether they're in range or whatever. The swappy answer is to just send raise from all points. So first we wanna build like a box around us, right? And we wanna say anything in our potential vicinity can become something that we could bump into, right? Now you can whittle this down, but I don't have the time to go through all the specifics and code that out. That's gonna be a nightmare on stream. So we're gonna do it quick and dirty. So what I'm going to do, let's see, how do we want to do this? What I'd like to do is we're going to get float diagonal size, and that's going to be vector2.distance, the distance between the top left and the bottom right point. And this is just going to just cast a wide box over our vicinity, and then we'll capture anything that it hits. Hey Ellie, what's up? Yeah, we could get specific and optimize with it, but that would take time to develop here. Obviously, we're gonna slim it down, but just to get something working right now. And again, this is just a test. This is just a test controller. None of this is final. It's just proof of concept, experimenting, etc., etc. So I'm going to take that diagonal size, and I'm going to add the, I gotta do this down below. I'm going to add the move distance times 2. Just to make sure that we've covered everything. And then what I can do here is do a box cast over our position to capture all of the stuff around it. So let's see. How do I want to do that? Box cast. Or I'm sorry, an overlap. A box overlap. Not a box cast, but not box overlap. I misspoke. Yeah, box cast is weird. Unity physics is weird. I'm not going to get into the specifics of what's wrong with that, because there could be an hour-long discussion. But when you, TLDR, when you use something like a circle cast or a box cast or whatever, it doesn't actually move the object up to the other object. It leaves a essentially random gap between them. And it's hard to, at least we found it very hard to rectify that random variance. And so we decided we can't use box cast. We'll have to do our own movement. Which sucks because box cast is really good. Otherwise, it's fairly accurate except for like where you end up once you bump into something. But whatever, we're not using that. Okay, so I think, should we do this before or after? It should probably be after. No, it should be before. Is that it? I don't know, let me think for a second. Yeah, probably should be before we do the corner range. Because you want to get the full distance in there. You want the full distance of them firing at you. And then you can manipulate the distance value in move distance to start off your corner race, so the corner race don't have to search as far. Because I think if you do it the other way, it won't work. I think if you shorten the reverse raise, that they potentially won't find you accurately. Alright? Let's see. Would that actually be the case? Let's do a little experiment. Okay, we're gonna move. I don't know. Does this work? Let's see. Hold on. Let's say we got another collider here. Just a little orb. And we actually hit that, right? And this is, instead of the full, this is what? 10? Instead of 10, we get 8. Or actually, the distance between us is 7. So we actually hit 7 here. How's that sound? Wait, oh, I'm sorry. You typed something. I suppose you can get away with a bounding box that's the shape of the collider, plus the movement vector. Yeah, I think that's what we ended up doing. I'm just not concerned about it right now. That's all. This is just a test. We're taking more information than we need to, but the concept is still solid. I'm just not worried about the specifics right at the moment. Okay, so this is 7. This is 10. Fire them all. You could. You could. Okay, and so I'm gonna move up to 7. Yeah, so if we give this 7, it will find us, right? Yeah. I guess it doesn't matter which way you do it then. Yeah, because you're just trying to find the closest. So if you shorten this ray, it shouldn't matter. Because if you're going to go this far anyway, it's still going to hit you. Yeah, okay. Well, because there are more points that are going to be firing from the reverse rays, then let's do the corner rays first. Because what will happen in that case is once the corner arrays are done, it may have reduced the size shooting backwards, which means there's less stuff to sort through. And it might save us some CPU time. Okay, we have to construct this carefully, so 1 fire corner arrays, 2 fire reverse rays, and then 3 make the final move. So we need to figure out how to do the reverse rays. We're gonna need physics 2D dot overlap. Let's see, overlap box all. Yeah. Okay, it wants a size. It'll be transform that position, and then our once a vector 2 size, so new vector 2 diagonal size, no, diagonal size. Doesn't wanna, oh, I spelled it wrong. Okay, what else does it want? Angle? I'm gonna say 0. I think that's just a rotation thing. Then there's a layer mask. Minimum depth, blah, 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 blah. Okay, we don't need anything about that. And it's gonna be collider 2D. Again, it's an array. I don't like that. I don't know why. Or is there an overload to send to the list? No, there's no overload to send to the list. I don't understand that. That's just asking to have garbage collection. Why does Unity do that? Maybe there's a way to do it. I don't know. Okay, then 4 I equals 0, I is less than overlap results that length 5 plus. And we'll probably refactor this too. We'll see. Right, that's what I've been telling you, Tim, the whole time. That's why I'm not doing the line walking now. Excuse me. Okay. We'll do tank controls here in a minute too. Overlap results, so var overlap collider. What's the overlap results? Okay, so this gets us a collider 2D. And what we need to do is we need to determine what it is and whether or not we want to deal with it. So first of all, just like last time, if it is us, we don't count that. We're not shooting ourselves. So, okay. The overlap collider is us. That is our self. Don't count. Okay, now let's see. I'm not worried about any line walking right now, period. We're not talking about that. That's later. That's yet another step above. We're just talking about detecting objects at range. Just calm down, Tim. We will get to it eventually. Just gonna take time. Just take a damn chill pill and calm down. Oh my God, Tim's riding my ass on this thing. You let me go. I know what to present and not to present. This will be the final step we can do today, just FYI. So now we need to take. This casts our overlap box, right? Was that the last song? That was the last song. Guess we're going in overtime. That's good. We're not too far off from being done here. Overlap collider, yeah, okay. So if it's ourselves, we don't worry about that. Yeah, the next thing is to determine what this thing is. Now, this is quick and dirty. This is just quickie and dirty. We don't, probably won't be doing this normally, but box collider 2D box equals overlap collider as box collider 2D. So what this does is it attempts to see, is this of type box collider? And if it is, it puts it in here. If it's not, then this is null. So if box is valid, then we can get the world positions from them. We're going to say private static vector 2 vector 2 reverse ray points point dots, no, just points. We're going to clear them before we do anything. Actually, no, we don't need to clear them. We don't need to. I think this will do it for us. So box dot get world space points. Remember that method from earlier I showed? I created my own extension. Well, guess what? There they are. Then we can take this and shove it off into its own routine. Probably gonna have to refactor this immediately. Because the other one is the polygon collider 2D. I'm just gonna call it poly. And if poly is good, then we can use poly. I've created one of these get world space points for the polygon collider as well. That uses the least amount of garbage collection possible. So the thing is, once we get these points, we don't need to check this one, obviously, because it's not going to be right. If this is correct, we don't need to do this. And that's where I'm going to immediately have to refactor this. I'm going to have to say, much like we did the process ray corner, private float, because we're going to return that move distance, right? Private float, check reverse rays, and we're going to need the list of points. And honestly, that's pretty much it. I mean, we need the direction and the stuff too. So here's the thing: the direction, the ray direction, the reverse ray direction is actually negative, because we're doing the opposite movement of what we're normally doing. And actually, while I remember that, let's make that positive, just to make this example less confusing, right? So vector 2 reverse ray direction equals the negative ray direction. We have to shoot back. Remember in our diagram here, we're shooting back from the corner. We shoot forward, we shoot backward. Corner shoot forward, reverse ray shoot back. And you can just literally just negative the direction. And that gets you the reverse. So, vector 2, ray direction, float, move distance, our good old friend move distance. And we're going to return move distance at the end, but what we do in the middle is going to be the fun part. So, for I equals 0, I is less than, we're going to cache this int world point count. I'm just going to say point count. Point count. Reverse ray points. That counts. Oh, and then point count I++. Now maybe I'm paranoid, maybe I'm delusional or dreaming, but it seems like when I do this, it actually slightly speeds up the for loop and not have to keep calling count. Now that can be dangerous if you're removing or adding things while you're doing the loop, then you're going to want to use count. But if you don't need to do that, you can just cache it like that. I find, maybe I'm paranoid, maybe I'm wrong, but it seems like when I do big heavy loops, I get better performance if I cache that number first. So I'm just going to keep doing that until I get told otherwise. Okay. So here's the trick, where here, the point corner ray, we want to take everything except us. We want to do the opposite. We want to take only us. Which means we need to search through every single result that comes through this ray. This is actually going to be a double loop, so I should rename this to ray ID. Or I'm sorry, not ray ID. Point ID. Because we're going to do a double for loop here. We need to 1, fire the reverse ray. 2, search through the results for our only, we'll say only our collider. It helps sometimes to write down what you want to do in advance like this. So, the ray results equals physics 2D dot raycast all. Now our origin is going to be the point. And point ID. Our direction is going to be the ray direction. Our distance is going to be move distance. Now here's the thing, if we do actually encounter us, we can actually stop searching at that point, because there's only going to be one us that's been encountered by that singular ray. It's going to be the closest one. Remember what the documentation said, that the order that you get these raycasts in are sorted by the distance away, starting with the closest distance. So the first result's always going to be the closest hit, the second is the second closest hit, and so on and so forth. Which makes it extremely easy to loop through these things. So I'm going to say hit ID equals 0. hit ID is less than array results dot length. Now you can use that length here. That doesn't change. I think that's pretty free to use. So I'm not going to bother caching that ahead of time. I expect that it's just storing it in somewhere, and it's sending that back whenever you call it. So we need to see, is it us? It's honestly just one check. So I'm gonna see. We were hit by the reverse ray. I'm not gonna bother caching this because it's only one check anyway. You don't have to do anything special with it, I think, right? Yeah, we do have to get the distance, but it's only one additional call. So I'm gonna leave it that way. I'm not gonna bother caching. Okay, so then the same thing applies here. We want to now set move distance to the distance from the raycast. Ray results. Yeah, the distance. Now I'm thinking, do we need to do any special checks here? We've already reduced move distance, so I don't think we need to check if it's less than the move distance coming in. And that might actually be true here too. Might actually be able to even stop here at this point. Okay, we'll think about that in a minute. We've only taken the closest first valid hit, right? Yeah, okay, hold on. Let's keep focused here for a second. I don't think we need to check if it's lower than this, because it's either going to be the same or lower anyway. You can't get greater, because you're only moving that far. And the ray's only shooting that far anyway. But we are going through all points. So yes, we do need to check that. Because we are checking all points, all hits from all points. We do have to check every single point. Okay, so we do need to check. Is this hit the smallest hit? So if move distance is greater than our distance here, new distance equals that. So move distance, I say if new distance is less than move distance, I think that is easier to read. Yeah. If new distance is less than move distance, then move distance now equals new distance. In some way. I was thinking if were all shooting the same move distance, then you would have to see who's the smallest. Because you're both shooting 8, and the first one says 5, but the next one says 6. Well, you can disregard the 6 because 5 was already lower. But one ray is only going to hit us once. That's why we break out of here. We will get hit only once per ray. Don't need to check further on this ray. Then if we change move distance, we get back around here and do this again. Yeah, then we'll only have potentially equal to this, but never greater. Yeah, so this isn't even needed here. Right, just what I thought originally. This isn't needed. We're constantly shrinking that anyway. It's always going to be the smallest. Or the same. And that's fine. If it's the same, then whatever. Just set it to itself again, and that's fine. It don't matter. Yeah. So if it comes in here, it hits at a distance of 6 out of 10. They'll say, hey, we found us. We hit at a distance of 6. This was 10, now this is 6. And so it'll go again and it'll shoot. Now, if there was potentially another hit at 8 distance away, we'll never know. And we don't need to know. Because this has been shortened to 6, so all the next rays are going to be 6. And they'll be whittled down lower and lower and lower. So that's fine. And that actually requires less processing too, the smaller the ray is. So that's what we want. That's an efficiency thing. Shorten the move distance to the ray finding. And that's it. And we repeat over and over and over until we're done checking all the points in that collider. Yeah, and then we return move distance. And then we just keep redoing it for every collider. Yeah, okay, so here, we're gonna say continue, but we need to put this in the middle. The reverse ray points, the reverse ray direction, and move distance are all here, and move distance pops out. And this continue will say, okay, stop here, don't go down here, go back up here and start again. There. Oh. And we can do that down here. That way it'll go. And then you got this far, the collider was not compatible, so we skip it. You get past these two. We don't deal with circles or edge or whatever. Screw it. Yeah. I'm gonna do a debug readout for this too, so we can see it. If it'll work. Oh, I don't know what move distance was to begin with. Well, that's interesting. Yeah, right, I don't record move distance. Let's do that. Private float debug attempted move distance. You know what? Why am I doing that? I'm cutting out. I need to cut out the middleman here. Attempted box overlap size. That's what I need to do. Why bother recalculating? When we can just take the answer that we got, right? Then we don't need all this. We just have this. So then gizmos dot color equals color dot yellow Gizmos dot draw wire cube center transform. Oh no, that's not gonna work. Oh no, we need the original position. Private vector 3 position at beginning of update. Position. Oh, no. Transform that position. There we go. Now we have that. Then we can use that down here. Because at this point, when it draws a gizmo, it has already moved. It'll actually give us an incorrect view if we don't do it that way. Okay, new vector 3. Size is attempted overlap size. Debug attempted overlap size and 0 for Z, because we're not using Z, we're using 2D collisions. And I think that should be on. Alright, and then we'll go back up here and continue this. Okay, move distance will continue to get truncated and truncated and truncated until the cows come. Okay, so let's reevaluate this statement again, like I said. Move distance comes in at a certain value. It may have already been shortened somewhere. So it's only going to be as big as it possibly can to find a new impact. Or the same impact. So when we hit something here, we could just set it. Update with the shorter distance. And that's it. You hit the closest valid object. No need to search through the rest. There we go. We made it more efficient now. It doesn't have to search through the rest. And it will just report back that truncated value. And so on and so forth. Again, it's just going to bounce right through here, and then it's going to do the same thing when it bounces through here. And then we make our final. And if we want to be more efficient, we can actually say position at beginning of update. That's going to be where we were anyway, instead of having to call this again with the plus equals, because that generates this and sends it back. It's a small minor efficiency thing. It probably would mean more if you did a world position, so just dot position. It would take some time to process, unless they cache those. I'm not really sure what the backend Unity is. Then once you see the source code, so you don't know. I would expect this to be a little more, even just slightly more efficient to have cached this up front. Otherwise, technically, your oh wait, this is different there. This is position. Oh no, actually, I have to take that back. We don't want to do that. This is a mismatch between position and local position. This actually should just be position. Because we're using world scale for all of this. The rays are being shot in world space. Yeah, this should check, or it should set the world position. Yeah. So I was wrong to have local position there. Local position should be potentially less costly, but this is fine. This will be more accurate. If you mismatch them, you could have some weird results, depending on if it's parented to something or not. So yeah, let's keep this as this. Take the world position, and just to make this more explicit, we'll say world position at beginning of update. That's really what that is. See, this is the world space position, so we want to make sure those match. Okay, plus ray direction times distance. Yep, and then yeah, and here's our check reverse rays. Got that refactoring there. And we could put this in its own thing too if we really wanted to, but that's fine. We'll leave it there for now. Hey, let's see if this actually works, right? That'd be great. You know, if we did all that and it didn't work. Okay, we're gonna start off paused. Okay, so here's our yellow box, right? And so once we get to the point where our yellow box reaches one of these colliders, we should oh no, we're not gonna see those rays, are we? It's not going to record them, so we won't see them visually. But we should be able to see them in action. Should actually work, right? So let's just do that. See if it stops. Oh! Look at that! Look at that! How about it, boys? He shot a reverse ray. The reverse ray said, hey, you're close. Just get right up there and stop. How about that? Yeah, you'll see the bound is attempting to move, but it's not allowed to move any further than it is. How about that? Look at that, it's right on that point. And that's something. Alright, let's have some fun now. Let's see. How do we want to do this? Yeah, okay. I got an idea. We'll just do keyboard controls. Public key code. Left key. Right key. Up key. Down key. Private void update controls. Nah, we don't need to do that. Let's do it here. And okay, update controls here. And then prepare for movement. Okay, so right in here, yeah, so if we're gonna do bools here, bool, move left, move right. Up, down. Can I just do false equals false and it'll go through? No, it doesn't like that. How about this one? Let's see. Did that set all of them, or is it going to be real mad? No, it's unassigned. Okay. Oh, that's a pain. We'll do it the not lazy way, I guess. There we go. Oh yeah, then we can just say input get key. Yeah, they're holding the button. That's get key, and we'll say key left. Or left key left. We'll just set these correctly. Right key, up key, down. Okay. SOCD cleaning. If you don't know what that means, that's simultaneous opposite cardinal direction. And the TLDR is what happens when you hold left and right at the same time. You want them to do neither. Is the simple answer. So if move left and move right. Oh, is that I actually made that lowercase? Oh, that's a typo. I want that. Then move left equals false, and move right also equals false. And the same thing we want for up and down. So move up and move down are the same. Then move up and I keep hitting that key. I think my Radeon recording is just set to automatically off. Oh, I'm sorry, this is moved down. That was my Radeon software. I hit some sort of key mapping that it didn't like. So if you're moving left and right at the same time, or you're attempting to do that, then you don't move at all left or right. Trying to move up and down at the same time, then your up and down will be nullified. That's all that is. That's important because you can get some weird results if you don't do this kind of thing. And some games get really broken if you don't do that. There's some fighting games that don't do this, that if you hold left and right at the same time, you can block from either direction. I think Marvel 3? Marvel vs. Capcom 3, the vanilla version, I don't think did this. And so if you had a controller where you could hold left and right at the same time, like, I don't know, a DualShock 3, hold left on the D-pad and right on the analog stick, you could block from both sides automatically. It was an auto block. So you could never get crossed up. So, yeah, do this in your games. Don't leave this to chance. Okay, now that we do that, we're gonna need combination. We need to figure out the combination of inputs that we're trying to do here. So, let's see. What would be the easiest way to do this? This is going to look weird and perhaps may not be the most efficient, but I think this will actually make a lot of sense. Vector 2, move direction, or control direction, equals new vector 2. And so this is going to be the X, and this is going to be the Y, right? So I'm going to say if move left, then -1, otherwise 0, plus, I'll probably have to put this on parentheses, and this is why you don't want left and right to be active at the same time, because then you can do this if you want. Say if it's right, then it's positive 1. And so this will always be 0 plus positive 1 or negative 1 plus 0. But it's a quick and easy way to write this kind of thing. And then comma. And then you do it with move down and move up. So in Unity, a positive Y value moves up and a negative Y value moves down, as opposed to traditional of them being reversed. And so same thing. It'll always be negative 1 plus 0 or 0 plus 1 in this case, because these will never be true at the same time. Yeah, actually it would work out anyway, because you'd have negative 1 plus 1 would be 0, but I guess if you let them both be there. So this gives you your control direction. And let's see, we want to normalize this. Yeah, we want to normalize this, so control direction dot normalize. Let's see that. Yeah, it changes the vector to have magnitude 1. This way, here's what happens if you don't do that. Actually, be a better way to put it. We made a vector. A vector is a direction. Starts here in the middle, right? And we said if we're going to the right, then it's 1 over to the right, and it's neither up or down. Or if we're going to say we're going up and right, then it's 1 to the right and 1 up. That's your direction. However, the distance between here and here is longer than the distance between here and here. So in old games, when you did diagonal movement, like in old Zeldas, pretty sure Link's Awakening does this. Your diagonal movement is faster than your forward movement, because it's adding the 1 and the 1 to get you over here. What it should be doing is it should be normalizing that so that you have a circle of directionality. It would be like that. So instead of putting you all the way up here, you should only be going about this far. That's probably like, let's see, if I make a circle here, oh. Yep, and I was pretty much right on the money. It would be that. And this would be the same distance from the center, like that. And this, of course, would be quite a bit more. That's what normalize does. It takes it from here and it shrinks it down to make sure that this is a distance that's consistent all the way around. That will save you a lot of headache. Okay, so now that we have our control direction, we can move in that direction, right? Hello, Peeper. Amber? Peeper's out here. You want to come get her? Hello. I'm sorry. Yeah, want to say hi to chat? What? What you doing? Them chicken noises. What are you doing? You can't be out here today. You're going to get in trouble, and I can't watch you because I'm streaming. You're going to get in big trouble. Look at. You afraid of the microphone? You don't know what it is. What? 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 Okay. Here she is. Okay. Aww. He's like, aww. Chicken. Chicken time. Let's see, do I plus these? You know what? I'm gonna just take the transform right out of here, because we're not gonna worry about that right now. We just want to move in the direction that our control is going. Okay, and then our movement speed stays the same. We don't have to worry about that. And that's also why we normalize this. That might be all we need to do. Okay, so left key is going to be A. We're going to use the WASD. Okay. Right key is D. Up key is W. And down key is S. Alright, see what happens. Oh, here we go. Here we go. Look at that. Oh, I got stuck. Uh-oh, I got stuck. Yeah, okay. So the reason for this... it makes sense. The reason for this is that when I try to move left now, it will attempt to move away because the rays are hitting this collider. Can't actually detach from it. They instantly hit this wall, even when they're firing in the opposite direction. And they want to do that. Let's see. I don't know if there's a quick fix for this. Other than... Okay. There might be a quick fix for this. It's not a good fix, right? But I'm going to just move the player back a set distance if they encounter any resistance. So float, original move, not mode, move, distance. Okay, so at the end we can, if we save this right away, we can go at the end and we can say if original move distance is not equal to move distance. What this means is something was encountered along the way, shortened our travel distance. But what do we want to do about it? Reduce the distance even further, small amount, to prevent moving into the wall itself. Or to prevent moving, that's not accurate, moving exactly up to the wall surface. Otherwise, we may not be able to reverse direction and walk away. I think this should work. So we're going to get like a nanometer up to it, but then, you know, it's going to pull it back just a little bit. So move distance minus equals 0.1 f. Like really, that's it's just by a very small, imperceptible amount. I think that should work. I think that'd be a quick fix. This would not be the fix that I would do in game, but I think that this would be the fix. This should work. No, it still gets caught. Really? He's flush with it. That's so. I guess that won't work. I did minus, right? Yeah, I did minus. What if we did a bigger number? I was sure that would have worked. It's preventing you from moving all the way. But then does maybe the next update kind of undo that? Oh, there we go. Okay, it works when it's a bigger number. It was just too close. Okay. Oh, look at that. I can't go through any of the objects. How about that? See, we can't get stuck in the points. Let's move this guy out here. See if we get stuck on any points. Nope. Look at that. We can't go in. Oh, this one's gonna screw us up because it's moving. You notice that it's moving, so that one's gonna jimmy us up. I'm just gonna turn him off. This does not handle colliders that move outside of itself. This is only if the background stays static. But yeah, look, I can't get inside anything. How about that? We're getting there. Look at that. How about that? Hooray, round of applause. We did it. And that is the basics of collision detection between flat-surfaced objects that me and Tim have noticed. Copyright Mark and Tim 2021. I'm sure this is nothing new. I'm sure you could probably find this in a book somewhere, but we did it ourselves and we're happy. How about that? Moving down slightly diagonal. Yeah, so part of the issues here is that you do, when you try to do, if I hold down, he's not going to slide down. He's just going to stop, right? But that'll be up to you to figure out how you want your movement to work. You know, whether or not it should redirect his momentum to move him down, or whatever. Now, as we continue on this path, see if I'm holding down left or down right, of course he still won't move, because he's being stopped. He's trying to move down right, but it doesn't redirect him to go left or right. That would be a different system on top of that. So our thing is now, let's take this system here. So Tim and I have decided we're going to take this system here, which can detect these shapes and prevent them from intruding on each other, and then start to attach certain points on the player to walk along the ground and to interact with things. So that was where I was showing here. If I still have it. Do I still have it? I don't think so. Did I undo it? Oh, yeah. Here. That's what I was showing here, where I said that, I want the character at the center point to stand on here. Now you're gonna question, okay, but like, you can't do that. Your corner can't go in. It stops you. Like, what? You can't do that. This is where it gets really complicated and really tricky. But you would start to... The very basic idea here is that you would start to use this surface reference with these rays to check the surfaces of what you've collided. And when you do that, you can check the steepness. You can check if it's a floor or a wall, right? That's what we have here. Where all this extra info comes into play here. I'm just going to focus on one here. Well, now all of a sudden we know what it is. It's a box. We know it's where the point starts and ends, or the line starts and ends. We know the steepness. We know if it's a floor. We know if it's right or left of us. Starting to get the picture. Now we can start making exceptions to these rules. Oh, well, if it's a floor, then the bottom left and the bottom right corners aren't going to collide with this. We're going to let him fall through the corner, and it'll collide with his bottom center. Hence, our center point. Bottom center point. I mean, there'll be a top one too for centers, but, you know, just one thing at a time, right? Starting to get the picture. Corners, they're going to say floor. We don't interact with that. Fall right on down and wait till you hit your center. So we're going to have a separate ray for the center point, the bottom center point, and a separate ray for the top center point. So you'll have 6 rays. So now, right now we got the 4 corners, but we'll have 6 rays. And then we'll analyze what comes in and make a determination. Say we get a hit. It says floor. All right, well, that's our bottom right, our bottom left. We're going to ignore that. We're going to let it drop all the way down instead. But if it's a wall, then we'll stop at it, right? That's the next step. And that's where we're going to have to leave it today. Because it's over midnight. I know I started late, but everything's going to hell here. We got floods coming in. We got animals needing taken care of. World's coming to an end down here. So that's it for today. Hopefully you enjoyed that boring programming segment instead of the happy fun pixel art that we did last time. Oh, there we go. There's pixel art. Ricky's running. Oh. He's a little updated if you came in late. He's a little updated from last time. But there's no real super substantial changes. We changed the angle of the foot so that it's angled down a little more, I believe, in the front. And I know I've made other tweaks to it, but I honestly can't remember what they are at this point. Maybe some pant shading. I don't know if I changed the knees on this. I'm not really sure, but he still looks pretty good. At least for now, I'm satisfied with it. I know I need to do something with the head and the hair a little more, but those were really, really quick alterations. So I've got to really think about that one. Kind of wonder, let's see, one is here. Should that be black? I think it like looks too black, right? That's why I took that one corner pixel off. And that just looks weird. I don't know. I don't like the way the eyes look like that. That terrible, I guess. Anyway, whatever. We're done. I'll mess with it later. So yeah, that's the basics of the movement that we've figured out so far. And that core system that we've demonstrated today, that's what we've identified as the absolute basics for movement with non-square shapes. So things that can be rotated, things that can have multiple points on them. Like just to exemplify this, we'll turn the rotation off, right? And I'm gonna copy them too. We're gonna move them over. We'll move them over here. Well, we start like really messing with the shape, right? We start doing crazy stuff like this. Is it gonna hold up? I believe it will. I'll do it. How about something like crazy stuff? Crazy stuff. I'm gonna move these. Oops, I'm gonna move these. I guess this will have to go with it, and this will have to go with it. And that's fine, as long as it's out of the way. And here we go. Should handle this like a champ. You should not be able to get inside. Yeah, see? How about that? can get ourselves jammed in the corner and we can still get out. Okay. Now remember, the yellow box is just a proximity detection. That is not what we're colliding. We're colliding with the brown box on the inside. I know it's a little hard to see because it's kind of zoomed out, but you can see it here. See? Yeah, see where we pushed it back just a little bit? It won't get any closer to it. But yeah, look at that. Can't get inside. Now these things are rotating and moving, that's a whole other story. That's a different kind of movement. We haven't figured that part out yet. Uh-oh, what happened? Uh-oh, we had a glitch. Oh no, we have a glitch. Alright, well, either way, when we put the more advanced system in, this won't be so much of an issue. No, we got it somehow. But the point is, I think it's because I got them stuck in the middle here. The point is, that's the very basics. You want to shoot reverse rays from those points. You shoot from a vertex, you can detect a flat surface. And you just do that back and forth. You will detect all the flat surfaces between the two objects. You find the closest they can possibly get, and you put them together, and they smooch, and it's a happy ending. And that's literally, that's pretty much it. That's the basics, right? So that's how that works. You just, I guess, don't want to get too close or find a different solution for when they do get close. Now, when they're snapped together with the lines, obviously they're touching, so you've got different rules for that kind of thing. You know, obviously in this case here, this is like inside this one already. So like, what do you do with that? That's a whole other ball of wax. That's where the exceptions come in, but that's the basic idea. Okay, that is pretty much it. Let's do the most important thing. We're gonna save our work so that it doesn't get blowed up and we don't have to redo it. And that's pretty much it. So if you guys like that, and if you're on a platform that has a like button, I would really appreciate if you hit that damn like button. Smash it, punch it. No, don't punch it. Don't hurt your phone. Or whatever, your computer. Don't touch the computer screen. How about that? There's your tip for the day. Your greasy, crappy, oily fingers getting on the screen can actually damage the plastic sometimes. Or if you poke it. If you poke it too hard, you can bust the pixels underneath it. So never poke your screen. Shut up. Don't poke the screen. Also, be careful what you clean the screen with, because some things will eat that plastic away. And I've seen it. I've seen it happen. And it's really weird. Anyway, so I guess that's it. Schedule's up on screen. Sunday is gameplay day. I don't know what I'm gonna play. I have half a mind to play Dink Smallwood and make you all suffer. Maybe that's what I'll do. I don't know. Or I'll just play a fighting game. And I feel like I'm getting out of practice with fighters. Hey, new Melty Blood is coming out. Maybe we'll play Melty Blood to celebrate the new Melty Blood. I don't know. Tim, are you still here? You want to play Melty Blood? Alright, we'll be doing something on Sunday. That's just our random gameplay day. And then Monday, Pocket Fighter EX. And then Thursday again, we'll come back here for more of this. I'm not sure if we'll be drawing or programming. This is day by day, it may change. If you want to follow these projects a little more closely, I'll have the Discord link in the chat here, or is a link down below wherever you see this video. And we also have Patreon, so if you want to support my personal efforts in game development on this or any of the other projects, or my efforts in streaming, and you feel like throwing me a penny, then I would very much appreciate that. So where's my Patreon list? I have a printed list of patrons, and they're gone. Alright, it's a good thing I keep a PDF then. Always keep a PDF, right? Where is my PDF? Or did Yeah, it's March, right? Yeah, jeez. And it tells you how coordinated I am. What month is it? It's March. Alright, we've got Cameron Wow, Variant X, Omega Keo, Awakened Emperor, Angel Rory Luis, Uncle Roy, Mike Cruz, Taryn Williams, Corporal Chungus, Bryce Nago Ingam, AJ Engraved Spirit, Miles Griffin, Ben K, D Money 107, and LD Walker. Thank you guys super extra special much. You help keep things going. And for their trouble, they get preview builds, they get special updates. It's all there on the Patreon, patreon.com/GameDevScrubs. And that's it. Thank you guys very much. I'll see you guys Sunday and Monday and Thursday again. And scrub out.